Okay, these are some more samples from paper 5, alternative to coursework. If you are taking the core exam, you do have to take this paper if you did not do coursework during the year. Okay, so if you are taking core or extended, doesn't matter, you have to take this paper. All right, let's look at these questions. So the first question, we have some diagrams that are given and we have to read the measurements. Okay, so this one obviously is a voltmeter and the second one is an ammeter. You read them just like a ruler. Okay, so let's zoom in a little bit. All right, so the measurement that we're taking is right where the needle stops. So halfway between 2 and 4, of course, is 3, and we're going to be counting in 2s, it appears. So this mark here would be, sorry, not 2s, 0.2. So this would be 3.2, 3.4, and right where the needle lands is 3.6. So that's the measurement, 3.6, and you have to put the unit, so volts, or you can just write the word volts. Okay. Part B, state the reading on the ammeter now. Okay. Very similar, except different unit here. All right, now this time, this is a decimal point in front of the number, so that's 0.2. Okay. 0.2, 0.3 would be here, 0.4, that would be 0.5, 0.6, halfway between that, 0.7, 0.8. So right here is going to be 0.9, okay? And again, we're going to be counting in 0.2, okay? Well, 0.02 in this case. All right, so that would be 0.9 here, so this would be 0.92. Okay, that's 0.9 plus 0.02, which gives us 0.92. Okay, so each division we go up by 0.02. That's 0.92, and where the needle stops is 0.94. Okay. So here's our value, 0.94, and we put the unit A for amperes, or you could just simply put the letter A, that's fine. All right, that's the first two questions. Next one, we have an oscilloscope trace, and we need to state the amplitude. So this is showing us the signal for a wave, an electric signal. We need to find the amplitude. Now remember, the amplitude is the highest point on a wave when measured from the equilibrium position. Okay, so what we're going to do is take the two endpoints, or the highest and lowest point of the wave, and halfway between that is our amplitude. So this is the highest and lowest point. And we have 1, 2, 3, 4, 5. So halfway between there would be our amplitude, our equilibrium position. Right there, actually, where it crosses. Okay, and so the value for our amplitude is this distance right here. Or this distance, same thing. And so that's half. And if 1 unit is equal to 1 centimeter, then this entire distance is 5 centimeters. And so that distance is half of 5, which is 2.5 centimeters. So the amplitude is 2.5 centimeters. All right, let's look at the next question. So for this one, I will tell you what you're supposed to get, but you're going to need a ruler and a protractor, and you're going to actually have to do this one on the paper to verify. All right, so first we need to find the magnitude of the force. and all we're really asking for is the length here. So we need the length of this vector. So you're gonna take your ruler and you're going to actually measure it, and you should get about 6.2 centimeters. And we're given a scale that every unit is 5 newtons. So you're gonna say 6.2 multiplied by 5, which is gonna give you 31 newtons. Then you're going to find the angle the force makes with the horizon. Horizon, what does that sound like? Horizontal. Okay, so the angle that we want is this one right here. So you're going to take your protractor and you're going to line it up so that the 0 mark is here. And then you're going to read from the scale to find out what this angle is, and you should get about 25 degrees. Okay. All right, that's it for this video. The next video, we're going to look at the experimental procedure write-up questions.